Ooh, how exciting. We're gonna keep talking about exponents. This is awesome. Hey, so speaking of awesome, there's this property, this product property, where if exponents have the same base and you're multiplying them together, then you get to add the exponents. So 4 to the x to the fourth times x to the third is actually, you can add those together and you get x to the seventh because this represents x times x times x times x times x times x times x. So it's really 7 x is being multiplied together. So just like there's a product rule, there's also a quotient rule that happens here when we raise a quotient to a certain power. And that plays off like this, because what we're trying to do is we're trying to figure out our quotient rule. Well, 4 to the fifth power is 4 times 4 times 4 times 4 times 4, and 4 to the third power is 4 times 4 times 4. So 4 to the fifth over 4 to the thirds, you can recognize that 4 over 4 equals 1. So really, people look, it kind of looks at it as canceling, but really we're just simplifying it to 1. We'll call it canceling, but really it is simplifying. So this 4 over 4 is canceled, it's 1, and this 4 over 4 is canceled, and this 4 and 4 is canceled. So you're left with 4 to the second power. So 4 to the fifth over 4 to the third simplifies down to 4 to the second, which is 16. And you can, this is a rule that can play out, and we've kind of recognized that, is you can take your numerator's exponent, this is if they have the same base, and subtract the exponent of the denominator. Again, if they have the same base, and you'll be able to get 4 to the second. And this is played out in this situation. Here's a sample of it. 2 to the sixth over 2 to the second. It's 2 to the sixth minus second, and you get 2 to the fourth. If we're just talking exponents, variables, x to the fourth over x to the seventh, it's x to the fourth minus 7, which 4 minus 7 gets us a negative exponent. Again, which doesn't mean it's negative, it just means that it's small, or little, as I like to say. And we write that as 1 over x to the third because we don't want to leave an exponent with it. We don't want to leave a problem or an expression or an equation with a negative exponent if we can simplify that more. Look at this situation. We can still do this. S to the 3/4 power over s to the half power. So 3/4 minus half. We end up with this tiny little number that I can't read. But it ends up with a fractional exponent, which is something we can do. We can subtract fractions and we can add fractions. We just got to remember to get that common denominator to pull them together. And we can end up with fractional parts. So let's practice this up a little bit now that we've kind of seen it. So a simplified form of each expression. Oh, why not? Let's just start with a fraction. That's crazy talk, but we're going to do it anyway. So I'm going to take, both have the same base, so I can do this. So that looks like it's 5/2. It's a really small. And I'm going to subtract 2 from that. Now, let's see. So 5/2 is really, I can look at that as 2.5. So really, I end up with, wait a minute. I end up with like x equals, it should be to the half power. All right. And we can just leave it like that. That is simplified, leaving a fractional exponent. And remember what this means. Do you guys kind of remember that? That number represents the root. Yeah. So this actually is saying square root of x. Okay, I whispered that because that's from a different lesson. So the bottom number of the fraction is the root, and the top number represents the exponent. Okay, so the exponent here is 1, and the root is here, which is 2. Anyway, I'm going to move on to the B one. All right, if this is really interesting to you or curious, you're going to have to look back at an older lesson. All right, let's move on. All right, so I'm going to take my common terms, which is m, my variables, and I have 2 minus 5, and then, which gives me m to the negative third, and I'm going to look at my n's, so it's n to the fourth minus 3, and that's going to be n to the first. And these are the two pieces I have. I have m to the negative third and n to the first. This m to the third, negative third, means it's small. It's little, so it's going to move down my denominator, and n to the first is going to stay on the top. and that is mine. So b ends up simplifying to n over m to the third. How exciting. Speaking of exciting, why don't you guys go ahead and press pause and work these ones out. Simplify them out, and if you end up with anything, again, with a negative exponent, please shift it so that it is not negative. All right, take a look at each one of these, see how well you did. And fractional exponent, I just want to keep throwing this out there that when you have a fractional exponent, the top number actually is your exponent, and this bottom one is your root. So this also can be seen as the quad root of y to the first. There's the 1, and there's the 4. But anyway, this is how you would leave it in simplified form. D to the half, k to the fifth over j to the third. You can read these things. You got to pay attention to negatives, like in this situation. You got to pay attention really in this situations. I notice here that I ended up with x to the 0, which is 1, so I can drop off. I think that's all the funky stuff I ran into. You can use the property of dividing powers, so it's like the quotient rule in scientific notation. Woo, I know you guys like that. A couple key things about scientific notation. Remember, this number needs to be between 1 and 10, and it's times 10, and you have an exponent. Positive exponent is big, negative exponent is really, really little. So let's see what we got to do. What's the population density of this place in that year? So I'm going to take 1.21 times 10 to the 7th, and I'm going to divide that by 481 times 10 to, what number is that? Looks like the 5th. Okay, now this one, kind of same thing we do with the exponents, is I'm going to take like these coefficients and I'm going to divide them out, and I end up with 0.252. Now I'm going to deal with these bases, okay? So both the bases are 10, and I'm going to look at the exponents here. I've got a 7 and a 5, so it's 7 minus 5 because I'm dividing. So it's to the second power. So, well, we've got to make a couple of changes here. So let's take a look at it. Times 10 to the second, true. But this number right here is not between 1 and 10, so I got to change it. So I'm going to move it over. So now it's 2.52. Now it's between 1 and 10 times 10. And I got to change my exponent. When I move to the right, I drop it down 1. So when I move my decimal to the right, my exponent drops down 1. So this is my answer. Let's see. You get to do one. Ah, lucky you. All right, why don't you do a little pausey-wazy and give it a try. Okay, I'm going to take a look at it. In scientific notation, my answer would be this. And when I simplify it out by moving my decimal 2 places to the right, I end up with about 169 is the answer to this question. All right, I'm going to cover myself in pollen and run through a honeybee's nest because I heard it tickles.